We're now going to look at finding the real zeros of a polynomial function. When the polynomial function doesn't factor, then we have a pretty involved algorithm that can be used to find the zeros. It involves looking at the list of potential rational zeros, cross-referencing that list with the x-intercepts on the graph, and then using synthetic division to verify those zeros, which then enables us to factor the polynomial function. Before we get started, let's make note of a couple of things. We can expect a degree n polynomial to have n zeros. The number of zeros is going to match the degree of the polynomial. But some of those zeros could be real, some of the zeros could be imaginary, and some of the zeros could be repeated. But when taken all together, the number of zeros is going to match the degree. Another reminder is that we only get x-intercepts at the real zeros. If we do get an imaginary zero, we won't get an x-intercept there. So a polynomial with degree n might have n x-intercepts, but that's only if all of them are real and none of them are repeated.